3 to 5 from exam style questions from topic sound under the subject of O-level physics, and from the book written by Tom Duncan and Heather Kennett, published by Hodder's Education. Question number 3. Explain with reference to a sound wave what is meant by the term compression and rarefaction. Compression and rarefaction, a sound wave produced, for example, by a loudspeaker consists of a train of compression where the air molecules are closer together. Where the air molecules are closer is called compression, and where the air molecules are further apart in the air is called rarefaction. As this is shown in figure, this is compression, this is rarefaction. This is compression, this is rarefaction. So from compression to compression we have this wavelength. From rarefaction to rarefaction we have another wavelength. This is also a wavelength. So in question number B, state how far air compression and nearest rarefactions are apart in terms of wavelength of a sound. So from compression to compression is a wavelength, so compression to rarefaction is half wavelength. So B part. And C, a sound wave has a frequency of 220 Hertz and travel in speed with a speed of 330 meters per second. Calculate the distance between the consecutive rarefaction. So F and V, distance between consecutive rarefaction is the wavelength. So V is equal to F lambda. So lambda is equal to V upon F. So the speed is given, frequency is given. So that the lambda is 1.5 meter. This is part C. Now question number 4. Identify the state of matters in which sound waves travel faster and slowest. Faster in solid, speed of sound depends on the material through which it is passing. It is faster in solid than in liquid, and faster in liquid than in gases, because the molecules in a solid are closer together than in a liquid, and those in liquid are closer together than in gas. So the highest speed is in the solids, and then liquid, and lowest speed in air or gases. Describe how sound waves are used in sonar. Ultrasound waves are partially or totally reflected from the surface at which the density of the medium changes. This property is exploited in techniques such as the sonar and medical ultrasound imaging. Ships with the sonar can determine the depth of a shoal of fish or the seabed. In the same way, motion sensors also work on this principle. So this is transmitted and reflected signal achieved by sending the transmitting ultrasonic waves and receive the same reflected waves. Identify 2 uses of ultrasound other than sonar. In medical imaging, used in prenatal clinic to monitor the health and sometimes to determine the sex of an unborn baby. Ultrasound transmitter receiver is scanned over the mother's abdomen and detailed image of fetus is built up. Ultrasound can also be used in cleaning. Jewelry objects such as street lamp covers and other immersion tanks in solvent, ultrasound vibrators in the base are used. So this is other uses of ultrasound other than sonar. Explain why notes of same frequencies have a different quality when played on a piano or a violin. The same note on different instruments sound different. We say that notes differ in quality of timbre. The difference arises because no instrument except tuning fork or a signal generator emits a pure note that is of one frequency. So they have different kind of different additional frequencies. The other instruments have a different additional frequency. The shape of sound waves of the same frequency from a tuning fork and piano are displayed on the screen of an oscilloscope. Sketch the shape of the waveform from the tuning fork and the piano. A waveform of note displayed near a microphone connected to a cathode ray oscilloscope and can be displayed on the CRO screen. Those for the same note on the 3 instruments are shown in figure. This is tuning for the pure sinusoidal wave, a piano with a different additional frequencies. Here we have a violin with same frequencies. All 3 have the same fundamental frequency, but their additional frequencies are different in these two, and here we have no additional frequencies. The different shapes show that when they have the same fundamental frequencies, their quality differs because they contain additional frequencies, also called harmonics. The pure note of tuning fork has a sine wave and is the simplest kind of sound waves. Note that although the sound wave of CRO screen is transverse, it represents a longitudinal sound waves. So this is all from this chapter, and the next we will discuss some other sections in the next session.